Hello class, today we're going to start lesson 3.5 and we're going to learn how to write equations. This is going to be a two-part lesson and today we're going to work on part A. So let's talk about the I can statements real quick. The I can statements for today are I can write linear equations in point-slope form and I can write linear equations in slope-intercept form. So we have two different forms we're going to learn today. We're going to learn point-slope form and we're going to learn slope-intercept form. Now, students always say, how do you study for math? How do you study for math? Well, one way you can study for math is you can memorize these two formulas because they are different and they're both very useful in their own way. So by the end of class today, you should know both of these forms. So when you're going over things and studying for a test, what should you study in Chapter 3? Here's one of the main things you should study when you're studying for Chapter 3. You should study these three different ways to write a linear equation. Way one is point-slope form. Now, the most useful thing about the names of these forms you can use are actually in the name. Point-slope form includes, you guess it, one point and the slope. If we go down to the next one, we look at slope-intercept form. So, you guessed it, in this one, you'll also be given the slope, but instead of a point, you're going to be given the y-intercept. And to backtrack a bit, here are your formulas that you'll be able to use. And standard form, we'll get to standard form a little bit more in part B. And standard form isn't quite as useful as point-slope form and slope-intercept form. But standard form, essentially, we get our x and y on the same side, and there's no decimals or fractions, and here's your formula for that. But again, we'll talk about that a little bit more later. But the key part about this slide right here, and the key part of this part of your guided notes, these are things that you do need to study if you want to be successful on the quizzes and tests moving forward. So take these three forms, get yourself a note card or something of the sort, write them down and study these three forms. So throughout the rest of these guided notes in Part A, we're going to go back to those three different ways to write linear equations quite often. So keep them handy, but let's jump into example 1. Example 1 is kind of like homework problem 1, and it says, write the equation of a line with the given slope, m, that's the abbreviation, and the y-intercept, b. So slope is m, here's our slope, and y-intercept is b. And there we go. So, I said we're going to go back to those different ways quite often. It says slope-intercept form. So the first step you're going to do, and you need to do this on your guided notes, is you need to write down that form. And that form is y equals mx plus b. This is a really easy problem. We're given the slope. We need to substitute it in. So we have y equals, our slope is 3. There we go. X plus, our y-intercept is given to us also, and it's 6. And ladies and gentlemen, that is all we do. This was just a substitution problem. When we're talking about slope-intercept form, when we're talking about this form right here, which is this, all we need is the slope and the y-intercept. That's all we need. So, your answer to this equation, or this problem, excuse me, is y equals 3x plus 6. One quick note before we move on. In these problems, this y will always be there. Y will always be by itself. And you'll almost always have an x in the problem also. We don't substitute things in for the y and the x. The only thing we substitute things in for are for this m and for this b. The x and the y will stay in our final answer. So, moving along. On to example 2, which corresponds with homework problem number 4 on your assignment. Let's look at this one real quick. Again, the important thing is to look what form that they want. And it says, write the equation of a line with the given slope and y-intercept. And here's the key. This is what you've got to look for. We've got 3 different forms. We've got slope-intercept form, we've got point-slope form, and we have standard form. So one of the key things you must do is you must look in your problem and say, or see, what form do they want? And in this problem, they want slope-intercept form. So we're going to start by writing that down. It's key to always write down the form before you begin. And our form on this one is y equals mx plus b. I'm going to say it often. Remember that m, the number with x, is your slope. And remember that b, this number over here to the side, is always your y-intercept. Just a little side note, we hardly ever use the x-intercept. We almost always, 99% of the time, are going to use the y-intercept. So let's begin. This is just, again, a substitute and solve type problem because they give you all your information right here. So let's just substitute it in there. Here we go. Y. Remember, y is going to stay in the problem. We don't substitute anything in for y. Slope. The abbreviation is m. It tells us our slope is 0. X. Again, x does not come out. X stays in the problem. Plus b. Remember, b, the number just hanging out, chilling over there on the side by itself, is our y-intercept, is 5. There we go. Now, last example, we circled it and moved on, but we can do a little bit of simplifying here. Anything times 0 cancels out. So 0 times x cancels out. This goes away. So let's write what we have left down. We have y equals 5. And that is our final answer. Now, just to review just a bit, I'm going to throw a very messy coordinate plane over here. Let's talk about what we learned last lesson. Look at this equation. What is not in this equation that we typically have? An x. And if there's no x in the equation, that means it will never cross the x-axis. So this line is going to be a horizontal line that crosses at 5. So we'll go 1, 2, 3, 4, 5. I'll get my red line. And that, ladies and gentlemen, is about the best line you'll ever see me draw. There we go. So y equals 5 is a horizontal line, no x-intercept, and the last little review thing that we can say is what kind of slope does this line have? Hey, it has 0 slope, and we saw that right there. So that's how you do that problem. If your slope is 0, then like I said, it's going to cancel x out. Okay, now that we've done these 2 examples, you are ready to go to your homework on My Math Lab, and you are ready to do homework practice problems numbers 1 through 5. As soon as you're done with problem 5, you need to come back to this video and start watching it because we're going to do a different type of problems. Go work homeworks 1 through 5. We'll see you back here in a minute. Okay, welcome back. We're on example number 3, and example number 3 looks like homework problem number 6. And it's kind of more of the same, but let's go ahead and read this problem and see what they're asking us to do. It says, write the equation of a line with the given slope, remember abbreviation's m, and the coordinates of the y-intercept for b. So this is a little bit different. They don't just flat out tell you what the y-intercept is. They give you the coordinates, but here in a second you'll see it's just as easy. And here's the key. Again, for about the third to fifth time on this slide, you've got to find out what form they want. And they, again, for the third time in a row, ask for slope-intercept form. And as we've done thus far, we're going to start by writing that form out. So we've got y equals mx plus b. And to drive home the point, here's our slope. Slope's always the number with x. Here's our y-intercept. So let's do this. Just to speed things up a bit, we know that we're going to have y equals, I'm going to leave a blank, x plus. That's always going to be in there. We just have to fill in these two blanks. So our slope is easy. Our slope is easy. Our slope is 3 over 2. And I like to review as we do these things. Remember, slope is rise over run. So if I put a dot here, that means we would go up 1, 2, 3 over 1 over 2. So this is kind of what a line with a slope of 3 over 2 would look like, just so we start getting a visual. And then our y-intercept. Now, it's different. They don't just say b equals whatever like they did the last problem. They give us an ordered pair. But it's pretty straightforward. It's pretty easy. As long as x, I'm going to try to draw an arrow in here, a small one. As long as x equals 0, then this other number is going to be our y-intercept. So that's all there is to it. So our y-intercept in this problem will be 5/6. So it looked different. They just didn't flat out tell us, hey, your slope is 3 over 2 and your y-intercept is 5 over 6. They kind of tried to hide it from us a bit. But we know that if the x-coordinate is 0, then that is your y-intercept. So that's all there is to it. We can box this answer. And we can move on to the next problem. Okay, here we go. Example number 4, homework problem number 8. Find an equation of the line described below. Write the equation of the line in slope-intercept form solved for y. So, here's the deal. They want our final answer in this form right here. Y equals mx plus b. I would consider this one our first really kind of challenging problem. Let me give you a little hint. For those of you that are actually watching and listening to this video, you're going to get a pretty good hint here. In slope-intercept form, we need the y-intercept. We have to have it. No options. But if you're not given the y-intercept, and the first, the first 6, 7 problems on this homework assignment, you're given the y-intercept. They either have just told you y-intercept is 3, or they've kind of hidden it a little bit. They put it in a coordinate. But either way, you were given it. This problem is the first problem that does not give you your y-intercept. Look for it. It's not there. They don't give it to you. What this problem gives us is 2 points. And if you're not given the y-intercept, then we're going to start using one of the other forms called point-slope form. Now, some of you might be saying to yourself, hey, you know what? We weren't given the y-intercept, but we weren't given the slope either. You're right. You're absolutely right. But we can find the slope because we practiced it last lesson. So over here, what I'm going to do is I'm going to find my slope. And I'm going to use the formula that we all know. And again, you say, how am I supposed to study for math? Well, memorizing this slope formula is probably a pretty good way to start. Slope, m, equals y minus y over x minus x. So let's do this. Our y's are 5 and 3. So I'm going to go 5 minus 3. And remember, the key thing is, it doesn't matter which way you subtract your y's, but you have to go in the same direction with your x's. So in the denominator, I'm going to have to go 3 minus 5 with my x's. And I'm given 5 minus 3 is 2. That's a bad 2. I'm going to erase that. 2. And 3 minus 5 is negative 2. I always reduce, and I'm going to get my slope as negative 1. So there we go. Now we have our slope. We have our slope. So we have one of the two things we need. So matter of fact, what I can do, honestly, is I can go up here, and I can fill this in. We've got y equals negative 1 x plus, we're still missing our y-intercept. But now I want you to look what facts we have in this problem. I want you to look what facts we have. Here's what we know. We know we have the slope. But that's not it. We also have a point. Check this out. We have a slope and we have a point. And if you'll go back to the very, very beginning of our notes, there's a little thing called point-slope form. And since we have the slope right here, and we have a point right here, and just FYI, I could use this one if I wanted. I just chose that one. What we can do now is we can use point-slope form to get what we want. So let's use point-slope form to help us get our y-intercept. Here we go. Point-slope form. We've got y minus y1 equals m, that's our slope, times the quantity x minus x1. Now let's substitute and solve. As I said in slope-intercept form, nothing goes in for y or x. So this y is going to stay, but we are going to substitute something in for y1. That 5 right there is our y, equals our slope, which we found, is negative 1. Our x, remember we don't substitute anything for the regular x, minus our x up here is 3. Okay, now we're really close to getting in the form we want. All we're going to have to do now is distribute and get y by itself, and we've got slope-intercept form. So let's do a little bit of math. Distribute here and here. We get y minus 5 equals negative 1x plus 3, because negative 1 times negative 3 is positive 3. And then our very last step is to go plus 5. Now we're going to do it over here under the 3 because they're like terms. And our final answer, because these cancel out, is y equals negative 1x plus 8. Check that out. Slope-intercept form. Slope-intercept form. Negative 1x plus 8. This problem is a little confusing. We actually had to use point-slope form to get slope-intercept form. To be honest with you, you're going to use point-slope form a lot. It's incredibly useful. And sometimes we'll use point-slope form to get other forms, but honestly, 75% of the time, you're probably better off using point-slope form unless you're just flat out given your slope and your y-intercept. Unless they just give you those two things, you're going to use point-slope form almost always. You might say, well, the first 6 problems we didn't have to, and you're right. But on the first 6 problems, they gave you your slope and your y-intercept. So it was super easy to use slope-intercept form. But from here on out, they're rarely going to give you your slope and your y-intercept. So we're going to use point-slope form more than anything moving forward. Let's do one more quick example, and I do mean quick. This one won't take nearly as long, and hopefully you'll feel more comfortable with point-slope form. Moving along. Okay, here we go. Example 5 corresponds to homework problem number 9. It says find slope-intercept form. Remember, slope-intercept form means y by itself, so our final answer is going to look like this. Of the line whose slope is 3 and passes through the point of negative 6, 2. Look, I like this stuff. Call me crazy. But to me, this is like a puzzle. It's like a mystery that has to be solved. You've got to look for the clues that you're given. I like things that where there's clues and, you know, you're trying to solve something. Let's look for our clues. Our clues are here. Slope is 3. And our second clue is it gives us a point. Now, whoever invented these forms that we're using, point slope form, slope intercept form, they're really nice because they named them after what you need. Slope intercept form, we need the slope and the y-intercept. We don't have that in this problem. Point slope form, you need the slope and you need a point. So here's the deal. We have that in this problem. So that's what we're going to use. We're going to use point slope form to get our final answer. So here we go. I'm going to write down the formula as you all should. Our formula is y minus y1 equals our slope times x minus x1. There we go. Let's substitute the numbers in, and then we'll solve it out. Remember, we never substitute things in, or rarely. There are some cases we might, but we rarely substitute things in for your regular y's and your x's. So this y is going to stay y minus, okay, y1 is negative 6. So we're going to, excuse me, let me back up here. Big mistake. y1 is 2. Our y always comes second, so we're going to substitute a 2 in here. Equals. Our slope is 3. Parentheses. Again, remember, nothing goes in for the regular x and the regular y. Minus. Now here comes a little part that's tricky, but my students last year really caught on to it really quick. Our formula on both sides are subtraction problems. Y minus y, x minus x. But if we're going to substitute in a negative x, if we're going to substitute in this negative 6, and there's already a minus in the problem, what happens whenever two minuses or two negatives get together? If you said they change into a positive, you're right. So when I substitute in this negative 6, it's going to change to plus positive 6. And ladies and gentlemen, that's point slope form. If they want the answer in point slope form, you're done. You're completely done. You substituted in your slope. It's there in the blue. You substituted in your 2 points. The x is the 6, or the negative 6, and the y is the 2. You're done. But unfortunately, there at the beginning of the problem, right up here, it asks for slope-intercept form. No big deal. No big deal. All we have to do is get this y right here by itself. So let's do that. Let's distribute. 3 times x is 3x. 3 times 6 is positive 18. Let's drop down what we're left with. We're left with y minus 2. And our last step is to get that y by itself. So we go plus 2, y equals 3x plus 20. We can circle that. And there we go. So notice, we used two forms. We used point-slope form to get slope-intercept form. Now, we can look at this, and now it's fair to say that our slope is 3, which we knew that. We were given that in the problem. But check out this. Look what we have now. Our y-intercept is 20. So we started out with a point and a slope, and that's why we use point-slope form. But at the end of the problem, after we solved it out, we now know our slope is 3 and our y-intercept is 20. So there you go. You should now be able to do homework problems 8 through 10. When you're done with the first 10 problems, come back. We've only got 2 more problems to do. Okay, all this stuff we've learned, where does it come into play in real life? Well, here's our first example. It says the birth rate of a certain country in 1995 was 15.2 births per thousand population. In 2005, the birth rate was 15.05 births per thousand population. So it's going down. Part A, write 2 ordered pairs, X and Y, where X is the number of years after 1995 and Y is the birth rate per thousand. So here we go. Part A. We've got ordered pair number 1 and ordered pair number 2. All right, let's review. It says X is the number of years after 1995. So, let's see what we got here. Our first one looks like it should be this. Well, if it's in 1995, the common mistake is to put 1995 as your first ordered pairs, but it's very specific. It says X is the number of years after 1995. Well, in 1995, that's 0 years after 1995. And let's go ahead and skip down here and let's look at our next one. If we're talking 2005, how many years after 1995 is that? Simple subtraction or counting on your fingers or in your head, that would be 10. Okay, and let's go back up here. The next one should be easy. Y is the birth rate per thousand. So that would be 15.5, or excuse me, 15.2. And whoops, 05. There we go. That's part A. The tricky part about this one, obviously, is a lot of people will want to put the years right here, and it does not ask for the years. It asks for the number of years after. So just be careful right there. Okay, let's look at part B. Okay, use the ordered pairs from part A to write the equation of the line relating to years to birth rate. Write your answer in slope-intercept form. Well, again, we've got to look at the clues. And the only thing we have right now, look, do we have the y-intercept? Does anybody see the y-intercept? We actually do. If you're clever, you can find it. I almost didn't notice it either. The y-intercept. Does anybody notice the y-intercept? If you said right here, you're absolutely right. You got to be really clever to catch that. But remember, if x is 0, and in this problem it is, then we have our y-intercept. Okay, look, if we have our y-intercept, we're halfway there. Because remember, slope-intercept form, what do we need? We need the slope and we need the intercept. So we can go ahead and write this equation. We can go y equals, we'll have to leave a blank for slope. We don't have it. X plus 15.2. You got to be clever to catch that. You got to look for those zeros. But we can find our slope. we can find our slope. We can use our slope formula. We know our slope formula. We're good at using it. We've got y minus y over x minus x. Let's see if we can use that. Here we go. Let's subtract our y's. Let's go 15.2 minus 15.05 over, this should be easy, 0 minus 10. Remember, go the same direction. I went this way, so I had to go this way. So 15.2 minus 15.05 gives us 0.15 over negative 10. And if I use a calculator to reduce that or give me a decimal, I get negative 0.015. I'm going to have to try to squeeze that in up here. 0.015. Need to make sure I put my negative. There we go. There's our equation of the line. I can box this in. All right. Next and last part of this problem. Part C. Okay. Use the equation from Part B to determine the birth rate in the year 2015. Okay. So let's. First of all, I apologize about the messiness of this slide, but let's go back up into Part A to look at a clue. Here's a very big clue. X is the number of years after 1995. See, sometimes you've got to go back in a problem and look for the clues. So if it wants to know the birth rate in 2025, well, 95 to 205 is 10, to 215 is 20. So we're talking 30 years. So all we need to do is we need to use this equation. Y equals negative 0.015. X is going to be 30 plus 15.2. See, we can use these equations to kind of predict the future. So we substituted in what we want to know, which was 30 years. We put it in there. You can simply type it in your calculator, and you get y equals 14.75. And that's our answer. You should now, after doing this example, you should now be able to do practice problems 11 through 12. Pause this video and come back for one last example. Okay, our last example, example number 7, homework number 15. It says graph the equation x equals 3 over 8y. So here we go. We need to get y by itself. So we have x equals 3 over 8y. In order to move y, what we can do is, here's a little trick. This is kind of new for some of you. Let's put this in parentheses, and we can multiply by the reciprocal, which is 8 over 3. Now, if we do it to one side, we need to do it to the other. So we'll throw this side in parentheses and do the same thing, 8 over 3. And we get 8 over 3x equals, these cancel, because if you multiply a number by its reciprocal, they cancel out, you get y. Now, I've had a lot of people tell me, I like it when y is on the left side. If you'd like to rearrange this, you're more than welcome to. You can put y equals 8 over 3x, same deal. Okay, now if y is by itself, then we have a pretty easy time to graph it. So let's talk about our y-intercept. If there's nothing over here, and there's not, this is a big empty spot, what number could we put there to not change the value of this problem? A lot of times people say 1. Well, if we put 1 there, it makes it 1 bigger. What number can you add to another number and not make the value increase? If you said 0, you're right. So what we can do is we can plot our y-intercept. This is our y-intercept. Plot it right here. And we can use our slope of 8/3 to help us get another point. Remember, this is rise over run. So we need to go up 8. 1, 2, 3, 4, 5, 6, 7, 8, and over 3. 1, 2, 3. And we have 2 points. We can make a line. Please draw your line much straighter than mine. And there we go. The key to this problem was we always need to get y by itself. Okay, so this wraps up the notes. This wraps up Part A. After you've completed these example problems, you should be completely comfortable, or you should be ready to do problems 1 through 15. You should be able to complete the first 15 problems. If you have any questions, please don't hesitate to pause this video, rewind it, or pause the video and raise your hand, and we'd be more than glad to help you.